NASA scientists are continuing to monitor interstellar comet 3I Atlas even amid the ongoing US government shutdown, while Congresswoman Anna Paulina Luna has formally requested new images and data to be released for public analysis. Global observatories have launched a joint monitoring campaign through early 2026 to study this rare visitor as it recedes from the Sun, marking the most coordinated international effort yet to track an object from beyond our solar system. Since its identification in mid-2025 as an interstellar visitor, 3I Atlas has moved steadily through the inner solar system. The object passed its closest point to the Sun on October 29th, when astronomers recorded a sudden surge in brightness. This brightening suggested intense outgassing as sunlight struck previously shadowed ices on the comet's surface. Spectral data collected during the solar pass hinted at brief jets of water vapor, carbon compounds, and trace metals venting into space. While these phenomena are normal for comets, the pattern of acceleration caught scientists' attention. The object's motion showed small, irregular shifts that were not fully consistent with models of uniform outgassing. These deviations prompted researchers to refine their orbit and rotation models for 3I Atlas. The irregular acceleration is not evidence of anything artificial, but it provides valuable insight into how interstellar material behaves under solar radiation. Most researchers attribute these anomalies to asymmetric venting from the nucleus, possibly caused by uneven layering or rotation. Despite the federal shutdown, NASA's internal teams at the Goddard Space Flight Center and the Jet Propulsion Laboratory have maintained essential tracking of the comet. A briefing with Representative Luna was scheduled to discuss upcoming data releases and to reassure Congress that monitoring continues uninterrupted. Luna's office confirmed that the request came in coordination with Harvard astrophysicist Avi Loeb, who has been pressing for open access to the newest images. Loeb has renewed his call for transparency, citing fresh signs of brightening and what he describes as non-gravitational motion after the comet's recent solar pass. He and his colleagues argue that the physics behind such motion should be investigated without bias. This is not because it implies artificial design, but because understanding unexpected forces can expose new natural processes. The European Space Agency and several university-run observatories have now joined the observation network. The object is currently roughly 300 million miles from Earth and fading in brightness. High-sensitivity telescopes can still collect spectra to determine how the comet's coma, its gas and dust envelope, evolves as solar heating diminishes. This outward phase is crucial for understanding the object's composition. The comet's trajectory and changing light curve will help researchers model its density, spin rate, and internal structure. These data will feed into the International Asteroid Warning Network's campaign, running from November 2025 through January 2026. The campaign aims to build the most complete dataset yet on an interstellar body before it vanishes back into deep space. More than a dozen research institutions are sharing real-time observations through the network. The effort involves both professional and amateur astronomers, collecting data across multiple wavelengths, including visible, infrared, and radio. Spectroscopic measurements indicate that 3I Atlas's ice and dust share similarities with comets from our own Kuiper Belt. Yet some ratios appear distinct, particularly the carbon-to-oxygen proportions and nitrogen-bearing compounds. These differences suggest it likely formed in a colder, more distant protoplanetary disk, perhaps around a small, faint star. Understanding these chemical details could refine models of how water and organics migrate across the galaxy. If 3I Atlas contains isotopic ratios outside solar system norms, It would confirm that the chemical diversity between stellar systems is broader than previously thought. This would be an important clue for theories of panspermia and early planet formation, though these remain hypotheses that are not confirmed. The renewed attention on 3I Atlas isn't simply because interstellar comets are rare. It represents a living laboratory for testing theories about how planetary systems exchange material. Each measurement brings scientists closer to determining whether comets like 3I Atlas are common messengers from other star systems or rare fragments ejected under exceptional conditions. NASA and the European Space Agency have reiterated that the available data show no evidence of anything other than a natural comet. Still, they agree that its behavior warrants extended observation. This measured approach contrasts with the divided public reaction following the discovery of Oumuamua in 2017, when limited data allowed speculation to outpace evidence. What makes this event different is the unprecedented level of coordination. The observation campaign now underway is being coordinated through the European Space Agency and the Lowell Observatory in Arizona. The goal is to continue tracking 3I Atlas until it becomes too faint to detect, using instruments across both hemispheres to build a continuous timeline of its evolution. Already, preliminary data hint that the object's composition may evolve as it moves away from the Sun, possibly developing a faint ion tail. If confirmed, that would mark the first time such behavior has been recorded in an interstellar comet with this level of precision. These observations are helping map gas emissions, dust density, and compositional shifts as the comet cools. The events surrounding 3I Atlas show how space science and public policy increasingly intersect. Congressional interest in a single comet would once have seemed unlikely. Representative Luna's involvement underscores a new political awareness that discoveries beyond Earth have both scientific and cultural resonance. NASA has stated that all data collected during the shutdown will be publicly released once normal operations resume. The briefing with lawmakers is expected to outline how such interstellar detections fit into long-term strategies for planetary defense and scientific collaboration. The agency wants to ensure that monitoring capabilities remain intact even during government disruptions. The Pentagon's All-Domain Anomaly Resolution Office, responsible for analyzing unidentified aerial or space phenomena, issued a brief clarification about 3I Atlas. The office confirmed that 3I Atlas is fully identified and poses no security concerns. The mention was procedural, but it highlights the structured communication now used to prevent confusion between scientific events and speculative narratives. Data collection includes measurements of the comet's polarization, a property that reveals particle size and structure in the dust cloud. These measurements help scientists estimate how the comet formed and what conditions existed in its parent star system. Each observation adds another piece to the puzzle of its origins and composition. The broader astronomical community is already looking ahead to the next generation of surveys. When the Vera Rubin Observatory begins full operations, it will scan the entire sky every few nights with sensitivity high enough to detect many more interstellar visitors. Astronomers expect that events like 3I Atlas could become annual rather than once-in-a-decade phenomena. This shift would transform these fleeting encounters into a new research field focused on comparative studies of interstellar comets. Each future discovery will add statistical weight to models of galactic dynamics. Scientists will better understand how fragments are ejected from planetary systems and how often they pass near stars like ours. The irregular acceleration patterns observed in 3I Atlas remain a technical point of discussion among researchers. While most attribute these to natural causes, like asymmetric venting, a few anomalies persist that warrant further investigation. Understanding these unexpected forces could reveal new, natural processes we haven't previously observed in our own solar system's comets. The comet's behavior after its solar pass has provided particularly valuable data. The brief jets of material observed through spectroscopy, combined with the surge in brightness, offer clues about the object's internal structure. These observations suggest the presence of volatile ices that had been preserved since the comet's formation billions of years ago. As 3I Atlas continues on its outbound path, it remains faint but still measurable by the most sensitive instruments. The object's current distance of roughly 300 million miles from Earth presents challenges for observation, but the coordinated international effort ensures continuous monitoring. Each passing day provides new data points about how the comet responds to decreasing solar radiation. The campaign involves careful coordination across time zones and hemispheres. When 3I Atlas sets below the horizon for observatories in one location, others pick up the observation. This relay system ensures that no significant events are missed as the comet undergoes its final observable changes in our solar system. The data being collected now will shape how we study interstellar visitors for years to come. Scientists are developing new models and techniques specifically designed to maximize the scientific return from these brief encounters. The lessons learned from 3I Atlas will be applied immediately when the next interstellar object is detected. Within months, 3I Atlas will slip beyond the reach of most telescopes. It will leave behind terabytes of data that researchers will analyze for years. This information provides a clearer picture of how the Milky Way's stellar systems exchange matter across vast cosmic distances. The international collaboration sparked by 3I Atlas has created new partnerships between institutions that rarely worked together before. Universities, government agencies, and amateur astronomy groups have shared resources and expertise. This cooperation model may become the standard for future interstellar object observations. NASA's ability to maintain tracking during the government shutdown demonstrates the priority placed on this research. Essential personnel at Goddard Space Flight Center and the Jet Propulsion Laboratory have continued their work, ensuring no gaps in the data collection. This dedication underscores the scientific importance of capturing every possible observation before the comet fades from view. The spectroscopic data revealing distinct carbon to oxygen ratios in 3I Atlas compared to our solar system's comets raises fundamental questions about planetary formation. These chemical fingerprints suggest that the building blocks of planets may vary significantly between star systems. Such variations could influence the potential for life to develop elsewhere in the galaxy, though this remains a hypothesis requiring further investigation. As the International Asteroid Warning Network's campaign continues through January 2026, researchers are refining their techniques in real time. Each observation helps calibrate instruments and improve data processing methods. These improvements will benefit not just the study of 3I Atlas, but all future comet observations. The possibility that 3I Atlas might develop an ion tail as it recedes represents an exciting opportunity for scientists. Ion tails form when solar wind strips electrons from gas molecules in the comet's coma, creating charged particles that glow. Observing this process in an interstellar comet would provide unique insights into how objects from other star systems interact with our Sun's influence. Representative Luna's formal request for new images and data reflects growing public interest in space science transparency. The coordination between her office and Harvard scientists like Avi Loeb shows how academic research and political oversight can work together. This collaboration ensures that scientific discoveries reach the public while maintaining rigorous standards for data interpretation. The measured response from both NASA and the European Space Agency demonstrates how the scientific community has learned from past interstellar object discoveries. By acknowledging uncertainties while presenting solid evidence, they maintain public trust while advancing knowledge. This balanced approach helps prevent speculation from overshadowing genuine scientific findings. 3i Atlas has connected scientists, lawmakers, and observatories in a rare global effort of discovery. The comet serves as a reminder that even across light years, our solar system is never truly alone. Material from distant stars passes through our neighborhood, carrying information about worlds we may never directly observe. The data collected during this encounter will inform the design of future missions and observatories. Engineers are already considering how to build instruments specifically optimized for detecting and studying interstellar visitors. These specialized tools could dramatically increase our ability to learn from these cosmic messengers. As 3i Atlas fades from view, it leaves behind more than just scientific data. It has demonstrated humanity's capacity to unite around shared curiosity about the universe. The international cooperation, rapid response, and transparent communication surrounding this event set a new standard for how we approach unexpected cosmic visitors. The comprehensive data set being assembled will serve as a benchmark for decades to come. Future interstellar objects will be compared to 3i Atlas, helping scientists identify patterns and anomalies. Each new discovery will add to our understanding of how planetary systems throughout the galaxy evolve and interact. The work continues even as the comet grows dimmer each night. Astronomers remain at their telescopes, capturing every photon of light from this visitor from another star. Their dedication ensures that when 3i Atlas finally disappears into the darkness between stars, it will have revealed as many of its secrets as possible.